Lesson 3 deals with inscribed angles in a circle. So our essential question is, how do I solve problems using inscribed angles and their intercepted arcs? Okay, the last lesson was really straightforward. The measure of the central angle equaled the measure of the intercepted arc. It gets a little more interesting with inscribed angles. Okay, in the first lesson you had the definition of an inscribed angle, which is an angle with the vertex on the circle and two sides that are chords. So if I look at my example down here, angle ABC is inscribed because B is on the circle. The intercepted arc is what we're talking about here with arc AC. Okay, the arc that lies between the endpoints of the inscribed angle. The measure of the inscribed angle equals half the measure of the intercepted arc. So that means the measure of angle ABC equals 1/2 the measure of arc AC. Now that's the formula I memorized that deals with this. Okay, it does work backwards. If I know the measure of arc AC is, let's say, 80 degrees, then the measure of angle ABC is half of 80, or 40 degrees. I can go the other way, though. If I know the measure of angle ABC is 30 degrees, for example, I can double that to get the measure of arc AC. So the measure of arc AC is 2 times the measure of angle ABC. Forwards and backwards on that formula. If you don't do forwards and backwards easily, memorize them separately. Okay, what happens when you intercept the diameter of a circle? So let's look at the diameter of the circle here. That's BC. Okay, and my inscribed angle is angle BAC. Well, when I intercept the diameter, right, the intercepted arc that I'm looking at, what do we call BC? BC is a semicircle. What's a semicircle equal? 180 degrees. So if my intercepted arc is half of 180, this is a right angle. The measure of angle BAC is 90 degrees. Right? The hypotenuse of a right triangle is the diameter of the circle. That's important. If you can remember that, you can save yourself a lot of time. You can reason it through, starting with semicircle equals 180, and this is inscribed, so take half of 180. But if you know it, problems go a lot faster, and time is often of an issue on tests and quizzes. Okay, so how do I find the measure of an overlapping arc? Well, an overlapping arc occurs when two or more inscribed angles intercept the same arc. What in the world do I mean by that? First off, we have a new vocabulary word. Okay. Second, let's take a look here. If I look at inscribed angle A, B, D, right, I am intercepting arc AD. If I look at inscribed angle A, C, D, I'm intercepting the same arc. If two inscribed angles intercept the same arc, the angles are congruent. This makes sense, right? Angle ABD is half of AD. Angle ACD is half of AD. Well, they equal the same thing. So the measure of angle ABD equals half the measure of arc AD. The measure of angle ACD equals half the measure of arc AD. Therefore, the measure of angle ABD equals the measure of angle ACD. Overlapping arcs. Color, for me, is critical, right? I actually trace the angle in a color, and that lets me see exactly where I'm intercepting the circle. What happens when you inscribe a quadrilateral in a circle? Inscribe. A quadrilateral is inscribed in a circle if all four vertices are on the circle. Okay, we inscribed that right triangle. I'm going to come back here and show it to you. Right, triangle ABC was inscribed. All three vertices of the triangle were on the circle. Here, we have quadrilateral ABCD. All four vertices are on the circle. So inscribed is another vocabulary word for you. The cool thing about this is that opposite angles have to be supplementary in order for this to work. So the measure of angle A plus the measure of angle C equals 180, and the measure of angle B plus the measure of angle D equals 180. So, what kinds of parallelograms could I inscribe? Squares and rectangles. Squares and rectangles, the angles all equal 90 degrees, so opposite angles, 90 plus 90 is 180. A rhombus won't work. A parallelogram will not work. What kind of trapezoid could I inscribe? An isosceles trapezoid. Opposite angles are supplementary was one of the properties of isosceles trapezoids. All right, so let's take a look here. Angle WXY is intercepting arc WY, so half of 62 is 31 degrees. Arc DGF is the intercepted arc for angle DEF. So double the angle equals the arc. 226 degrees. PQR. Ooh, I'm noticing something right here. PR is a diameter. That makes PQR 90 degrees. Oh, these are a lot more fun. Okay, let's see. I'm looking at it, and they gave me RS, SU, UT. I'm missing one arc up here. All the arcs in a circle have to add up to 360. So if I do 360 minus 64, minus 139, minus 75, what do I get? 82? RT is 82 degrees, and I think I need that because I'm trying to find R, S, T, and that intercepts RT. So half the arc is 41 degrees. RUT also intercepts RT. Also half of the intercepted arc, 41 degrees. Alrighty. Take a minute, pause your video, try number 5. Alright, so this starts off as a straightforward overlapping arcs problem. Alright, I went over ABD in one color and angle ACD in another, and they both overlapped arc AD. So they both have to have the same measurement. I set them equal to each other, solved for x, and then put x back in order to figure out the angle measures. Now the angle is half the arc. When you have an inscribed angle, it is half the intercepted arc. So I had to double my angle to get my final answer there. Just a little on the sneaky side. Let's try number 6. We've got a lot going on in this picture, don't we? Let's see. I know that opposite angles have to be supplementary. So Q and S are supplementary. 180 minus 93, that's 87. That's right off the bat. Now, let's figure out R. There's angle R, and it intercepts this arc. Oh, 126 plus 90, right? 126 plus 90 is, having a hard time adding, 216. So let's see, from here, 216 to here. The inscribed angle is half the intercepted arc, so half of 216 is 108. Now let's look at angle P. Angle P. Angle P is going to be this. Oh, golly. Well, we don't know QR and we don't know RS. So we might have to back this up a little bit and look at something else. Let's look at angle PSR, which would intercept all of this, right? PSR is 87. So RQP is double 87. 87 times 2 is 174. Now I need to subtract out the piece I know, 126. So 174 minus 126, and this piece is 48. I'm finally getting somewhere here. Okay, I still need to know SR though. So let's take a look at 93. So arc RSP is double 93. 93 times 2 is 186. Subtract out the 90 that I already have, and this piece is 96. So now I can get angle P. 96 plus 48 is 144. Divide that in 2, and my angle is 72 degrees. That one was fun. That one was a lot of fun. Number 7's a lot simpler, so pause your video and try it on your own. Opposite angles of an inscribed quadrilateral are supplementary. So those two angles, angle T and angle V, have to add up to 180. Set up the equation and solve, and x equals not -3, but +3. All right, so for your summary, tell me the relationship between an inscribed angle and its intercepted arc, between a how a right angle is inscribed in a circle and how a quadrilateral is inscribed in a circle.